Welcome. We've been doing a lot with linear equations, but something that goes along with linear equalities is linear inequalities. Now, the first thing I want to do is I want us to realize the one difference between solving an inequality versus an equation. If I give you something like 3x plus 2y equals 7, and I ask you to solve that for y, what we want to do, and in other words, get it into slope-intercept form, is we're going to minus the 3x over, or minus the x term off of the left side, moving it to the right side. We get 2y equals, now 7 and negative 3x are not like terms, so we write it as a negative 3x plus 7, because we want the x term in front. And then we divide by 2, and we get a y left by itself on the left side of the equation. We're going to divide both the negative 3x term by 2 and the 7 by 2. So we find out our slope is a negative 3 halves x, and our y-intercept would be 7 halves. Now that's a linear equation, and we did a couple steps in order to get it to be in this slope-intercept form, which is y equals mx plus b. Well, we're going to introduce an inequality. 3x plus 2y is less than 7. So instead of an equal sign, we're going to do a less than symbol, or a greater than symbol, or less than an equal to symbol. And solving it is very much the same method. We want to remove the term that has the x, so we get the term with the y by itself. We're left with a 2y is less than, again, those two are not like terms, so we do a negative 3x plus 7. And then we divide, again, both sides by 2, leaving just the y equals, not equals, is less than, because we're doing an inequality. Again, both terms are being divided by 2, so we get a negative 3 halves x and a plus 7 halves. And we've solved it just the same as if it was an equation. No difference in the steps, unless we introduce negatives. And I want to introduce that a little bit differently. And what I mean by that is this. You do agree that 3 is less than 5. I can add or subtract any amount I want. Add or subtract any amount I want, and the left will always be less than the right side. If I add 105 to the right side, and I add 100 to the left side, 103 is still less than 105. If I subtract 100 from 3, so I'm going to subtract 100 and get negative 97, and I subtract 100 and get negative 95. Now think of a number line. On a number line, negative 97 is left of negative 95, which means it's less than. So adding or subtracting, the inequality symbol never changes. In other words, the left side will always be less than the right side, no matter what I add or subtract. But when it comes to multiplication, it depends on whether it's a positive or negative. And what I mean by that is this. We all agree that 3 is less than 5. Let's multiply by a positive number. And I don't care what the positive number is. So I could multiply by 7. If I multiplied the left by 7, that's 21. If I multiplied the right by 7, that's 35. And 21 is still less than 35, or the left is still less than the right side. If I multiply by, I don't care, 100, 300 is still less than 500. So as long as I'm multiplying by a positive, the left side will remain to the left of the right side, or in other words, will still be less. But if I multiply by a negative, so again, this was timesing by 7, this was timesing by 100, but now let's say I times by a negative 7, then this will be a negative 21, and this will be a negative 35. Now think on a number line. Negative 35 is way to the left of negative 21. So that means the right side is now less than the left side. That inequality, I had to flip it if I multiplied by a negative 7. And it doesn't matter what size the negative is. If I multiply by a negative 100, times by a negative 100. This would be a negative 300 on the left, and this would be a negative 500 on the right. That right side is now less than the left side, so that inequality flipped. The same thing applies with division. What I mean by that is if I give you 100 is less than 200, can't see that, I'm sorry, there we go. You all agree 100 is less than 200. If I divide by 5, both sides, so I'm going to divide by 5 on both sides of the equation. 100 divided by 5 is 20. 200 divided by 5 is 40. Well, 20 is still less than 40. So if I'm dividing by a positive number, the left side will still remain less than the right side. But if I divide by a negative number, then this negative will become a negative 20, and this will become a negative 40. And again, think of a number line. Negative 40 is left of negative 20, which means the right side is now less than. So it flipped. So when we're solving linear inequalities, if you have something like this, 5x minus 2y is greater than or equal to, and I don't even care what the number is, 7. When I go to solve this, I got to think about whether I ever multiply or divide by a negative number in order to isolate the y. So first thing I'm going to do is remove this 5x, minus 5x, minus 5x from both sides, just like if it was an equation. The 5x's cancel on the left, leaving a negative 2y is greater than or equal to a negative 5x plus 7. Now I minused 5x. I wasn't multiplying or dividing. I can minus any quantity, and this inequality symbol doesn't change. But now I need to get rid of this negative 2 that's sitting in front of the y. I need to do that by dividing by a negative 2. If I divide by a negative 2, then this inequality is going to flip. And I'm going to have y is less than or equal to. I don't remove the equal sign, I just flip it. So now the left side is less than rather than the right side being less than. Now again, I'm going to divide each term. So a negative divided by a negative becomes 5 halves x. 7 divided by negative 2 becomes a negative 7 halves. And I've solved that equation for y. But you notice, because I divided by a negative, I ended up flipping the inequality symbol. So just remember that. That's the one difference. If you multiply or divide by, now this is the important part, negative, the sign flips. So write that down. When you multiply or divide by a negative, the sign flips. Otherwise, it doesn't change. Adding and subtracting any amount, positive, negative, I don't care what, adding and subtracting doesn't change it. Multiplying and dividing by a positive does not change it. It's when you multiply or divide by a negative, that's when the inequality symbol flips and faces the other direction. If you have questions, please bring them to class.